Assalamu alaikum. Today is our fifth lecture of Advanced Electromagnetic Field and Waves. As in previous lecture number 4, we already derived Helmholtz wave equation in term of electric field, which is equals to this: E equals to E naught e power iota kx minus iota omega t. Okay, this is the solution of Helmholtz wave equation in term of electric field. Similarly, in term of magnetic field is similar. Okay, in this you already know Euler formula: e power iota theta, which is equals to cos of theta plus iota sine of theta. Okay, and similarly there are two things in this equation. Is first is the real part and the other is the imaginary part. The real part, as I shown you here in this Euler formula, is basically the cos of theta is for the real part, and this with iota is basically the imaginary part of the wave. Okay, and so our real part of our this Helmholtz wave solution of Helmholtz wave equation is basically equals to E naught. Now this becomes equals to cos of kx minus omega t in term of when our real term. Okay, whereas omega you already know is the frequency and k is the wave vector, but when you take the magnitude of any vector it becomes a number. Okay, it becomes now wave number. Now there is because this is an electric field and it must have some direction, so that's why let's specify our direction. Let's your electric field is going in the x-axis direction. Okay, basically this x cap shows you basically the direction of electric field. Okay, and inside cos angle minus kz minus omega t, inside the wave vector this z stands for the wave vector propagation. Okay, in which your wave is propagating. This z is shows you the wave propagation direction. Okay, but this shows the direction of an electric field. Okay, and this negative sign shows you that your wave is propagating into the negative z direction. Okay, so this is how you can illustrate your wave equation. Okay, similarly by these notations. Let's take an example, because you know that let's suppose your electric field is moving into the y direction, and your also you can say now your wave is propagating into the z direction, and your frequency is 10 raised to power 8. This is not frequency, this is omega, which you know, which is the angular frequency, and omega is equals to, you already know, which is equals to 2 pi f. So 2 pi f becomes equals to 10 raised to power 8. Now if you want to find frequency, you just have to divide the value with 2 pi and you will get your frequency value in hertz. Okay, so if electric field in x-axis direction, then which h basically the magnetic field must be into the y direction, because you already know that electric field and magnetic field are always perpendicular to each other. Okay, so if your electric field in the x-axis direction, then h means magnetic field must be into the y direction with the wave propagates into the z direction, because you already know all threes are always perpendicular to each other. You can see basically this is current and this is, let's suppose, magnetic field, and my thumb is basically the wave vector. You can see it making all 90-degree angle. Okay, so this is if electric field in x, then y should be in opposite direction, means perpendicular in magnetic field in y direction, and the only direction remains is z, and z must be basically for the direction of wave vector. Okay, so means E, H and K are always perpendicular to each other. Okay, there is a system how you can find the direction of wave. Okay, there is a system known as right-handed system. Okay, so you can see here, just I illustrate coordinates, like this is my x-axis. For this you have to use your right hand. Okay, what you have to do, just you have to take your right hand. Okay, and you adjust your fingers in the direction of electric field. Let's suppose my electric field into the x-axis direction. So I can write here, and now I should have curled my fingers in the direction of magnetic field. So because this is right hand, and you can see magnetic field is into the negative z direction. Okay, yes, x-axis and magnetic field, this is for the wave vector basically. And if your electric field direction is x and your wave vector is z, so so your magnetic field must be into the y direction. So this is, first of all, I align my hand into the direction of electric field, which is straight into the x-axis. You can see straight x-axis as shown here. Okay, x-axis. Now what I have to do, I have to curl my fingers into the direction of magnetic field, and magnetic field into the y direction. So what I have to do, I have to curl my fingers. Okay, so you can see I will curl, so this is my alignment, and I will curl my fingers in the direction of magnetic field, which is y-axis, you can see here, and my thumb will incline the direction of basically the wave vector. Okay, which is in the wave vector. Okay, which is in the minus z direction. Okay, so this is how you can solve, illustrate your. Okay, so there is another method. Curl your fingers in the direction of electric field. Curl your fingers in the direction of your wave propagation, which is the negative z-axis. Okay, and your thumb will incline the direction of the magnetic field, which is the minus y. Okay, so this is how you can illustrate. Basically, now there is a proof. You have to prove your electric field. Okay, your electric field, your magnetic field, and wave vector k are perpendicular to each other. Now you have to prove this. Okay, first of all, you already know that your electric field wave solution is basically equals to this: E equals to E naught e power iota kx minus iota omega t. Okay, in term of source free system, we already know that the curl of electric field, basically you can say not curl, this is the divergence of electric field is equals to 0 in case of source free term. Now what we have to do, we have to take the curl. So this is the electric field, we have to take del curl. So del dot e means we have to take derivative of this, and let's suppose in x-axis direction, so it becomes a derivative of this becomes same this equation as it is, because epsilon naught is constant, and the derivative of e power iota kx is basically iota k. Okay, and this all expression is now same as it is. So this is our question basically equals to, so del dot e becomes iota k wave vector and dot e. Okay, now we know del dot e equals to 0, so your left hand side equals to 0, which is equals to iota k dot e. Okay, now divide iota other side, so k product of k dot e becomes equals to 0, and you know that in scalar product of two vectors, if your product is equals to 0, then this means they are both are perpendicular to each other. Okay, so it means k and e are perpendicular to each other. That's the thing which we required. Okay, we have to prove that e, h and k are always perpendicular to each other. So first thing, we all proved that k wave vector is perpendicular to e because their dot product answer is 0. Similarly, you can prove for the case of magnetic field, your wave vector k and b must be equals to 0. Then we conclude that our wave vector and magnetic field are also perpendicular to each other if this result comes. So how we can achieve to this result? Again, we have to take the divergence of magnetic field. We already know that the divergence of magnetic field is also equals to 0, but our solution of Helmholtz wave equation in term of magnetic field is basically b equals to b naught e power iota kx minus iota omega t. Okay, now we have to take the derivative with respect to, okay, x-axis. Now let's, because we are just assuming that our wave is going into the means our electric field is into the, or means our magnetic field is into the x direction. Okay, so when we take derivative, b naught is constant, comes out, this is as it is, and derivative of this becomes iota k, and because this is time dependent, and this becomes 0, so only left with this is as it is question, so this becomes b. Okay, so del dot b, which we know del dot b equals to iota k b, and del dot b we know equals to 0, so it becomes equals to 0, and this is equals to iota k b. Move iota to other side, and k dot b equals to to 0. So we can conclude that the curl of means divergence of the magnetic field means K and B are always perpendicular to each other. That's why their dot products are coming 0. Okay, similarly now we have proved that electric field with respect to K is perpendicular and magnetic field with respect to K is perpendicular to each other, but how we can prove E and B are perpendicular to each other, mean electric field and magnetic field are perpendicular to each other. This can be achieved by another formula of the Maxwell's equations. We already know that the third equation means the curl of, you can see the curl of electric field, which is equals to iota omega B. Okay, time harmonic form of Faraday's laws is this. Just we have to take the curl, so del dot E, we already know E naught e power iota kx minus iota omega t, iota b as it is, and b we already know that b is equals to b naught e power iota kx minus iota omega t. Okay, here k is your vector and it becomes equals to k and their direction in the x-axis, because we are assuming that our in the direction of x-axis only. Okay, now we have to take the derivative, because curl of electric field in x-axis direction is only equals to, it becomes iota k and e naught the same as it is, and iota omega, this becomes b naught, this as it is, and this exponential cancels with this exponential. We will only get final, this iota cancels with this iota, and we will get our final expression, and that was equals to k cross E naught equals to omega B naught. Okay, and now let's find k. K becomes we know that k is equals to omega under the root mu naught epsilon. Okay, mu epsilon, which is furthermore equals to omega under root mu naught epsilon naught n, which is the vector okay, unit vector cross epsilon naught. Okay, so equals to omega b naught as it is. And now if we want to find b, then b is equals to n cross E naught divided by c, because we know that here I shown you that, because we know that under the root mu naught epsilon naught must be equals to 1 by c. So this mu naught epsilon naught becomes equals to 1 by c. So n cross E naught divided by c becomes basically equals to b. Similarly, now we will find other aspects. Okay. And the other aspect we will find the value for h. Okay, we find that b equals to epsilon naught by c, and we will now prove that h naught will comes E naught divided by z naught. Okay, so how we can prove this? We can prove this by taking another Maxwell's equations. Okay, we already know that the curl of electric field is also equals to iota omega mu naught h. Okay, h is basically the magnetic field. Now we have to put the values here. We know the E value is E naught e power iota kx minus iota omega t equals to iota omega mu naught as it is, and h value we know that h equals to h naught e power iota omega x minus iota omega t. Okay, now same exponentials cancels with this exponential. We will finally get with this after taking derivative, it becomes iota k E naught and it becomes iota omega mu naught h. Okay, iota cancels with this iota. Okay, and k, this becomes equals to this. Now you have to put the value of k, which we know equals to omega under the root mu naught epsilon naught, and n epsilon naught as it is equals to omega naught mu naught h naught as it is. Now omega cancels with this omega, and you will get your final answer. H naught is equals to n cross E divided by mu naught. Okay, mu naught, and this we already know that under the root mu naught epsilon naught equals to 1 by c. That's why 1 by c is here, you can see. Okay, so our final expression for h naught is equals to this n cross E mu naught c. But there is another method. If you not put the value of directly 1 by c, just divide mu naught by here, and it becomes under the root epsilon naught by mu naught, and there is another, and this is equals to another constant that is equals to 1 by z naught. Okay, under the root epsilon naught divided by mu naught is equals to another constant that is 1 by z naught, and this is as it is here, okay, and Z naught is basically equals to 128 pi, and further it is equal to 377.7 ohms, where Z naught is basically the impedance in free space. Okay, so this is your final expression of B naught, and this is your final expression for H naught. Now let's take an example, a short example. Let's see here that let's suppose this is your electric field is given that your electric field in x-axis direction, and cos, which is 10, means with their amplitude E naught, and cos of e power 8 t minus kz, okay, and electric field in volt per meter, which is the unit, okay, and you have to find E. Basically you have to find B magnetic field, and you have to find H. Both are the magnetic fields, okay, basically. So first of all, let's find H. We already know that H is equals to epsilon naught 10 divided by Z naught. So because your electric field in the x-axis direction, so your magnetic field H is must be into the y direction. Why? Because your electric field in x and your wave vector in k, so there is the only direction left is y, which is the 90 degree to both of them, so your magnetic field must be in y direction, okay. And E naught value we already shown in question that it is 10, so 10 divide by Z naught, and divide by Z naught, and other wave vector as it is cos of 10 power 8 t minus kz, okay. Similarly, now if you want to find B, you know the formula, which is equals to E naught divided by C, and but in that case again your magnetic field in the y direction, because your electric field in the x direction and your wave vector into the z direction, so B must be into the y direction. So y is the direction, E naught, which is the amplitude, we given 10 divided by C, and all other aspects are same. So this is how you can find electric and magnetic field, okay. Now what you have to do now here is you can find there is another method you can find by using Maxwell's equation, okay. So how you can find this again by Maxwell's equation, there is another concept, okay. Let me show you how you can find uh, our last topic of this, okay. So by using Maxwell's equation, how we can find the basically the magnetic field, okay. So we already know by the Maxwell's equation that the curl of electric field that was equals to iota omega mu naught H, okay. So we have to find H, so we have to move iota to the other side. So and because iota move other side divides, and when it comes, you can see here, okay, the omega and mu naught goes other side downside in denominator, and iota also goes to the denominator. But when we move iota from denominator to numerator, it becomes with minus sign, okay. That's why minus sign is here with iota in the numerator. Similarly, we have to, because there is a curl of because you can see here curl of electric field means you have to take in curl x y z, partial by partial x, partial by partial y, partial by partial z, okay. But your only electric field, let's suppose, is going into the x-axis direction, so only x-axis is here, y and z is 0, okay, in this scenario, okay. So now you have to take the cross multiplication, okay, matrix multiplication. You already know x, this you have to multiply this and this, then which minus this, and this is constant, then you have to this multiply by this multiply by this, then plus z, this and this is constant. Now you have to multiply this with this and this with this, okay. You can see here, after multiplying matrix multiplication, you will get your final results, that is equals to minus iota, okay, omega mu naught equals to this. But you can see our E, we already know what is our E, basically equals to let's suppose, let me explain this from my board. I already solved it here. Let me show you, okay. This is from here, okay. Basically using Maxwell's equations, so this is our final expression after multiplication, and now this x-axis is already 0 on the y-axis and z-axis, but in because we know our E is basically equals to this. Let's suppose our electric field wave solution is basically equals to 10, okay. Basically equals to, let me show you this here, let me show you this. this is our basically electric field value. Okay, this we have to derivate. Okay, 10 cos electric field in x direction, 10 cos 10 power 8 t minus kz. This is our expression of solution for electric field, and now we have to derivate this with respect to z, and we have to derivate with respect to y. There is no y term, so when we derivate this with respect to y, so this becomes equals to 0. Only you have to derivate with respect to z, and with respect to z, and you will get your final expression 10, and derivative of cos is basically sine 10 power 8 t minus kz, and when you derivate the angle iota kz, it becomes okay minus iota k. Okay, if there is iota, so iota here, if no iota, so no iota here. Okay, so minus k is basically answer of derivating of, because there is no time dependent. So when you derivate this with respect to y, with respect to z0, and when with respect to z, when you derivate this with respect to z, you will get your minus k. So this minus k here, and y direction as it is, you can see here. Next, what you can do here, this minus and this minus becomes minus minus plus, so you can see plus iota by omega mu naught. Let's suppose there is iotas, and iota multiply, it becomes iota square minus 1 and minus minus plus 1. Okay, and now you have to put the value of k. You know the value of k is basically under the root mu naught epsilon naught. Okay, here I put the value of k here. Okay, this omega k value is under the root omega naught epsilon naught w outside. Okay, so this omega cancels with this omega. Okay, here, so what you can see now is that there is mu naught and upside also, so under the root mu naught divided by mu naught becomes basically equals to under the 1 by under root mu naught, and there is epsilon naught also, so final expression is under the root epsilon naught divided by mu naught. Okay, and 10 y direction, sign this as it is, and where there is a trigonometric rule that it was sine of angle sine of theta plus pi by 2 is basically equals to cos of theta. Okay, so this expression is also equals to cos of theta, so you can write it as cos of 10 to the power 8 minus kz, similar. Okay, no worries about that, and we know that under the root epsilon naught mu naught basically equals to 1 by z naught, so you can see direction 10, which is, and this equals to 1 by z naught and cos of air. So you can see this expression for H magnetic field, and this expression we directly found, and this expression we found by the using Maxwell's equation. So this is how you can find. So that's all for today's lecture. Okay, this is our lecture number 5 of advanced electromagnetic field and waves, in which we discuss basically the solutions of electric field and magnetic field of Helmholtz wave equation solutions. Okay, we will then discuss their imaginary part, their real part, and then we will I showed you that what is the right hand system. Okay, this is all I wrote on my board, so you can take snapshot of this for your further revision. Okay, so then we discuss about right-handed system, and in right-handed system we proved that how electric field, how magnetic field, and how wave vector k are perpendicular to each other. Okay, we can show by diagram. I showed you by diagram, and I showed you mathematically with proof 1 by 1. Okay, each aspects your wave vector with electric field perpendicular to each other, your wave vector with magnetic field perpendicular to each other, and finally your electric field perpendicular to the magnetic field. Then we proved that the value of B naught expression, okay, in term of electric field. Then we find the value of H naught, okay, in term of electric field, and then we have a how we can find basically magnetic field and magnetic field, and then we have a practical example how we can directly find the magnetic field, okay, if electric field is given. Okay, if the electric field expression is given, we can easily find the magnetic field, okay, directly. And there is a new method which we discussed at the end of the lecture, and that method was by using Maxwell's equation how you can basically prove the value of magnetic field, means basically how you can prove the value of H. Okay, with the help, if you have electric field solution, Helmholtz wave equation solution is given, so you can easily find the magnetic field, okay, by this scenario. So that's all for today, our lecture number 5. So stay tuned with us, we will upload more lectures for advanced electromagnetic field and waves. Thanks for watching. Allah Hafiz.